Hi, this is Michael Pfeifer. This is another episode of the Metal Conversations podcast. In this episode, I'm going to talk about the two fundamental metallurgy principles that are critical for understanding metallurgy. These metallurgy principles are at the basis of, or are the basis, and are at the foundation of understanding metals and metallurgy and being able to engineer processes that are capable of producing tons of metals every minute in different forms. They also underlie our ability to engineer metals that are used in components, that is, selecting the materials used in components that are able to meet performance requirements, reliability requirements, and preferably be low cost. And these fundamental metallurgy principles are also the basis for our understanding and the steps we take to solve problems related to the metals used in products. These problems include component failures and quality problems. Now, I'm going to be talking about how these principles apply to metals, but they actually apply to all materials. But since I'm a metallurgist, I'm going to focus on metals and metallurgy. The first principle is that the properties of a metal depend on a metal's composition and the microscopic structures present within the metal. Metal composition refers to the elements present in an alloy. So would be the main element. So in aluminum alloys, it's aluminum. In steel, it's iron. In brasses and bronze alloys, it is copper. And then there are also alloying elements added and impurity elements that are added. The composition of a metal, and its main element and the alloying element and impurity elements, that influences the properties. The other thing is the microstructure. Microstructure refers to these features and structures that are microscopic. We need a microscope to see them. But even though we can't see them, they have a huge influence on the properties of a metal. So for metals, these microscopic structures include phases, grains, grain boundaries, and dislocations. These different structures influence the properties in different ways, and we can manipulate the microstructure of a metal in order to manipulate the properties of a metal. So there are two general levers for modifying the properties of a metal: its composition and its microstructure. And by understanding the effects of composition on microstructure, we can design metals that have the properties necessary for a particular application. The second fundamental principle is that the microscopic structures present in metals depend on the metal's composition and also how the metal is processed. So for processing, this refers to both mechanical treatments such as cold rolling and drawing, and it also includes thermal treatments such as heat treating. And then there's also thermomechanical treatments, which is when we use both temperature and mechanical treatment at the same time, such as hot rolling. So we can change with processing. We can use heat treating or cold rolling to modify the grain structure of a metal, or the number of dislocations present in a metal, or the phases present in the metal, or the phases size and shape. And by doing that, we will modify the properties of a metal. Altogether, these two concepts are important. These two fundamental principles are important. First, that the composition and microstructure affect the properties, and the second, that we can use both composition and thermal and mechanical treatments to modify the microstructure in order to modify the properties. I'd like to give one quick example of how these two principles apply to carbon steels. So we can take steel and we can modify their composition and we can modify their microstructure in order to modify their strength and their hardness and other properties of the steel. So for example, let's consider a 1045 steel. That is a steel that contains 0.45% carbon. We can take that steel and we can hot roll it, and the result will be a steel that consists of grains of ferrite and regions of pearlite. So the microstructure consists of ferrite plus pearlite. We can take that same steel and then put it through a spheritization anneal, and that will cause the cementite plates in the pearlite to form cementite particles, and the resulting microstructure will be spheritized cementite, so particles of cementite dispersed in a matrix of ferrite grains. And that material will have lower strength and lower hardness than the hot rolled steel, and it'll also have better elongation or better ductility than the hot rolled steel. and it will also have better machinability than the hot rolled steel because of the shape of the cementite particles. Alternatively, we can take the hot rolled steel and we can put it through a through hardening heat treatment, or we can also take the spiritized steel for that matter and put it through a through hardening heat treatment. And the result will be the formation of martensite in the steel. And a steel that consists of martensite is very hard and very strong. It also has poor machinability. But we would use that heat treatment on steels perhaps after fabricating components, and the steel might be in the full anneal, or excuse me, in the hot rolled condition or the spiritized or normalized condition. And again, we're using a heat treatment to change the microstructure in order to change the properties of the steel. So that's just one example of how understanding the two principles and applying them to steel is important for understanding the composition to use and the heat treatment to use. We can also take the steel and change the composition, and it will change the strength and the hardness of the steels, and also affect other properties in addition to the strength and hardness. So these two fundamental principles are the foundations of the science of metals or metallurgy. The application of this enables us to engineer metals. We can design manufacturing processes capable of producing various forms of metals: bar, sheet, plate, tubing, that has different compositions and different microstructures that result in different properties. And the mills that produce these materials have a great understanding of the two fundamental principles and the knowledge for the specific materials that they're working with in order to continuously produce tons and tons of material over and over again that have the properties needed for the people that will be using their products. From the perspective of designing components, understanding these two principles is important for, number one, for selecting the alloys necessary for a particular application in order to meet the requirements for the application. And for requirements, we think about performance, which includes strength or ductility, also fatigue resistance, maybe electrical conductivity. Also ease of fabrication if we're thinking about design for manufacturing. And then there's also reliability properties of metals or characteristics. This includes materials corrosion resistance or creep behavior or fatigue behavior or wear behavior. So when designing components, it's important to think about the metals that are needed and think about engineering the component to select the right metal and to select the correct fabrication processes, and also perhaps additional heat treatments that will result in the final microstructure that will give the properties required for the application. And when people do understand these two fundamental principles, and then they understand how to use these two fundamental principles to engineer metals, then they can successfully engineer products that meet performance reliability requirements at low cost. Finally, when problems arise, whether it can be a component failure during use, such as a fracture or corrosion failure or wear or fatigue failure, or it can also be production quality problems, either manufacturing quality problems or supplier quality problems. By understanding these two principles, that helps inform the steps that we take. We understand the information that we need to get in order to understand what's going on with the metals, and then being able to use the tools necessary to get the information needed about the metals to understand its microstructure and its composition and its properties. And then by understanding the relationship between properties and composition and microstructure and processing, and using the data from the analysis of the metal, we can understand what happened to the metal and then figure out what to do to prevent the problem from occurring later on. So it's important that people have a good understanding of these two fundamental concepts in order to be able to engineer metals and solve problems. And without a solid understanding of these two principles, and then understanding the actual metallurgy of different materials, it's difficult to continuously produce metals that meet requirements and to design components that meet requirements at low cost. and to quickly solve problems. Now, as I said, these concepts apply to all materials, not just metals. They apply to metals, ceramics, polymers, and the other new materials that are being developed. Those materials have different microstructures and also different manufacturing processes compared to metals. So the discussion for those is a little bit different, but the general concepts are the same. It's important to understand the effects of composition of microstructure and manufacturing processes and how they relate to the properties in order to get the materials we need and to design components that are low cost and that work as needed and to solve problems quickly when they arise. I hope that this was enlightening to some of you and perhaps will put you on the path to wanting to learn more about metallurgy or the other materials you work with. If you have any questions or comments, please email me. My email is mike@imetllc.com. And if you haven't already, please subscribe to the Metal Conversations podcast series to receive alerts for when new podcasts are released. You can subscribe on Spotify, Google Podcasts, Apple Podcasts, and all the other usual outlets. And one more thing, there is a video that is a companion to this. If you go on our website, you will see that video, and it's also available on YouTube. Thanks for listening, and good luck with your metals.